Now, so when you are finding out the area bounded by two graphs, basically, now let's say the function f of x is here and function g of x is here, and you want to find out this area bounded by both the graphs. So in that case, what you do is basically A and B, you first find out the intersection points, either using technology or manually. So let's say this is y1, this is y2 function. We generally try to take this one. Let's say area is nothing but you integrate y1 minus y2. So upper curve minus lower curve between A and B. This is the formula that you notice in the different textbook. Y upper minus y lower integration dx from A to B. Now, sometimes what happens is that I am not clear about which curve is the upper curve and which curve is the lower curve. So in that case, you can just find out this area and attach an absolute value, because if you're not sure, then you just area can't be negative. So in that case, you can do this. Now I'm just going to take a question where, like, your area is bounded by the graphs. Let's say the simplest example I can take is sine and cos. This is the sine x graph, and now if I'm taking the cos x graph, I'll just redraw this. This is 180, this is 360. So here the cos x graph is actually starts from here and crosses here at 270, and then this is. So let's say if I wanted to find out this area bounded by the graphs here, in this case. So the first thing that I will do is to find out the intersection between the two graphs. So I'm just going to equate, let's say sine x equals to cos x and find this intersection. So let's say this is the sine x graph and this is the cos x graph. And I want to find out the intersection of both these graphs. So you get tan x equals to 1. So the first answer is, so tan x is 1 in the first quadrant, here or here. So this angle is either pi by 4 and this is pi by 4. So actually the first answer that you get is this answer is pi by 4. Remember that when you're calculating area, never use degree measurement, because area will never be correct in degree measurement. So use radians always. Now, once you got this answer is pi by 4, this answer that you get here, the next part, this is pi by 4. Now, next answer is pi plus pi by 4. So this answer is 5 pi by 4. So finding the correct intersection is important. Now, coming back to the integration now here. So upper curve here is my sine x function and lower curve is cos x function. So you integrate this between pi by 4 and 5 pi by 4. So when I integrate this, sine integration is cos x, negative cos x, and negative cos x is sine x. I mean, the sine cos x integration is negative sine x. So if you put the values now here, pi by 4 and 5 pi by 4, you get the exact values for the exact answer for the area. So you can find this answer by like substituting the limits. Like this is going to be negative cos uh, 5 pi by 4, negative sine 5 pi by 4, minus so minus of minus, if I take this entire minus common, so it will become plus. So it is sine cos pi by 4 plus sine pi by 4. So this is the answer for this part, and these two you can find out. So this answer is actually negative root 1 by root 2, and it's become positive. So 1 over root 2 plus 1 over root 2 plus, this is also 1 over root 2 plus 1 over root 2. So the answer is 4 over root 2, and that you can write as basically nothing but 2 root 2. So this is the exact answer for the area bounded by both the graphs. Now, when you have more than one area that is bounded by two graphs, now for example, let's say I have a function which is something like this, and you notice that there are two values, like here the function is enclosing two of the areas, and if you wish to find out, let's say this is a1, I mean this is, let's say, x1, this is x2, and this is x3 here. So what you do is, let's say this is my upper curve, y upper, y lower, and here this curve is y upper and y lower. So actually when you look at the equation of the curve, this is y1, this is y2. So equation of the curve is not changing. So what we do is, in this case, is we take x1 and x2, first area. That upper curve here is nothing but the y1 function. So y1 minus y2. Um, then, so y1 minus y2 plus, then you take the second function is x2 to x3. Here my y2 is the upper curve, you can see. So y2 minus y. So this will give you the area of this entire like combined shaded part. So this is how you find the area bounded by two graphs. So let's just kind of have a quick look on the calculator. So how do you do this on Casio calculator? So now let's say here I want to find out the area bounded by two graphs using calculator. So first I'm going to quickly go over the concepts on the area bounded by functions. Let's say I'm just going to quickly erase these functions here. Now first thing what I do is, let's say I take lnx graph, that's the first one, lnx function, and I can take the next graph is actually the sin x graph. Sin x graph. So here you notice that the area bounded by the graph is actually after some point of time. So I'll just take sine of 2x graph with a little bit bigger amplitude. So let's make the amplitude 3. All right, so now you can see here that the area is bounded by actually 2 points here. You notice that the area is bounded by the graphs. So first thing what you notice is that in this case you find at the intersection. So if I find the intersection, actually this is like, actually it's like a section B type question. You have to find out solution of find out where sin x actually equals to ln x, or like 3 sin 2x equals to ln x. You're gonna plot this graph and this graph, show this as a relevant working, and say that answer using the graph. Answer is x 1.5, and the other answer is let's say second answer is 3.34. So these are the two of the areas in this case. Now assume that I have given some higher range as well in order to find out the one more intersection. So the answer is 4.45. So let's say this 4.45. Now let's say here this question, the domain will be specified that it is from 0 to 5. Now here what I'm going to do is that I want to find out the combined area. So this area, ideally what I'm going to do is when they expect us to write the integral, it is going to be 1.5 to 3.24 ln x, that's my upper curve, minus 3 sine 2x, that's the lower curve, and plus the other integral will be 3 sine 2x, because that's for this region. When you see it's my upper curve is 3 sine 2x minus the ln x curve. So this is from, let's say, 3.24 to 4.45. So this is the answer when you write manually. Now, how do we evaluate this on calculator directly? So first what I'm going to quickly show is one by one how to find the area using the calculator. So I'm just going to keep one function at this moment. Let's say I want to find out the area bounded by the graph of ln x, firstly from let's say 1 to, let's say, pi. So I wanted to find out this area by the graph. So in this case, what you do is just straight away use the GSolve, and then you go on to integration, then go click on integration, and you put the limits whichever you want. So let's say I want from 1 until 5. So I'm just going to input that value here. So you can see that this is the exact answer I'm getting. Now second is that when it is, there are two curves, which is 3 sine 2x or something. So when you've got two curves and the area becomes bounded, then you use little different strategy. So let's say GSolve integrate. Now use the method called intersect. So instead of selecting direct integration, you select intersect. First area, this to this I want to find. So this area automatically is 4.49, 4.45, and then you do one more time. So GSolve, integrate, not integrate actually, make you go on to intersection, GSolve, integrate, and then press intersect. So don't select this point now, just select this as first point, then go on to the second point. So you find these two areas. So you can see that this area is 1.176, and you add them up. So so 1.1 and plus 4 point something will give you the answer. Now, in case if you wanted to find out the exact value directly from in the beginning, you didn't want to do 2 times, you could just do y1 so you could just plot the absolute value of, so plot option numeric absolute value of difference in the y values. So y1 minus y2 you do. So you can just click exit. You have got y1 function minus y2 function. Now here it doesn't matter wherever the graph is. So you're actually doing upper curve minus lower curve. Don't need the original functions now. So just deselect them. Don't delete them. And you got this function. Now just say integrate, GSolve integrate, and intersect. So So gsolve, integrate, and if you, because you know that the you already got the value from the intersection, so you could just put either those values, or you can just directly integrate from, okay, so the first root, because that's the where first time they're equal, this, and then the second part was actually 4 point something, which is this. So this is also a way to find out directly the area bounded by two graphs when the multiple areas are given to you. So that's how you do area under the graph on the calculator.